Right, so this is my next project. I'm essentially going to reinvent the wheel and redo the Diffie-Hellman key exchange between two computers on my own. So the layout's super simple, literally just two computers with one of my random routers in between them. And the idea is to, well, you're not actually passing a key, but you're passing the parts that make up the key in this process. I'll talk more about the Diffie-Hellman key exchange and the details in the next video, but this is just an outline of how the project should roll out. So here's the equation. It's y to the x mod p. And so the first step is obviously going to be running some script on both computers at the same time. So the first step, essentially the computer on the right is going to tell the computer on the left, hey you, I want to exchange encrypted data. The second one goes ahead and picks a random value for y and sends it to the, well, we'll call it laptop and pi. So then the laptop will say, okay, we'll confirm that it's 46750 for y, and makes another random choice. It chose 587902 for p. Again, this is all public data. This is unencrypted. Anybody could intercept this, but it shouldn't matter. And then sends it to the pi. Then the pi, when it gets that data, it chooses a random x value. This is the only private value in this process besides the final answer. So we'll say it uses a 155 for the x. Alright. It plugs into the equation and solves, and then sends the answer and the confirmation that it was using these numbers. So it says, right, we use these two numbers for y and p, and then my solution using my private x is 429508, and I did this math already. So the laptop receives that, it chooses a random x value, and we'll say 542 for this example, keeps it private, plugs it into the equation and solves. And then it says, okay, it confirms the other computer solution and then sends its own solution. Well, then there's an acknowledgement from the pi. And then we go to the last step here. The pi will plug in the laptop solution into the y position. All the other values remain the same. So its private x, which is 155, stays the same, and so does the shared value of p. So the answer you get, which in this case is 501932, that doesn't get passed. That becomes the key. And then the same step 7 on this side. The laptop plugs the pi solution into the y slot. All the other values remain the same, and then it should every single time end up with the same answer. So there we go, 501932, 50193, and this value here is never exchanged over the net, so it cannot be eavesdropped. Now you can eavesdrop everything else in here, the y value, the p value, and the solutions, but you cannot get the x value. Never exchanges hands, and neither does the final answer, but they come to the same final answer. This is a very basic overview of the Diffie-Hellman key exchange. I'll explain more about the actual math behind this in the next video.